So far, the six leptons were shown in experiments that they have no internal structure. So they are known to be the elementary particles. So on the other hand, hadrons in experiment shown that they have an internal structure, and we know that there are many types of hadrons. And for example, a neutron, which is a hadron, we know that the neutron has a zero charge, but we also know that the neutron has a magnetic moment. So normally magnetic moments, you can only have them when you have a spinning charge. So they come to conclude that inside the neutron, it must have some sort of internal structure. So instead of thinking of the neutron as having no charge, maybe they thought the neutron has no total charge. So in 1963, Gell-Mann proposed that hadrons are made up of a combination of three more fundamental particles. So he called the combination of three fundamental particles inside hadrons as quarks. So initially, he proposed three quarks, which are the up, down, and strange quark. And later on, it was shown that there is an additional three more quarks, which is the charmed, bottom, and top quarks. So these are the six quarks that we know, and so far we have discussed conservation laws. Particularly, we observe that in particle interactions, the baryon number must be conserved, the strangeness number must be conserved, and in addition to these quarks, new conservation law is added. So we have now the conservation of charm, and we have a property which is the bottomness and the topness. So quarks have a very interesting property wherein their charge is a fraction of the elementary charge. So in classical electromagnetism, we know that the fundamental charge is known to be E, in the sense that you cannot have a fraction of E or a decimal of E. But in quarks, in order to explain the magnetic moment of the neutron, quarks should have a fraction of a charge E. So, for example, the up quark has a charge of 2/3 E. The down quark has a charge of minus 1/3 E. The strange quark minus 1/3 E, and so on. So, as an example, here are some quark compositions of the protons, neutrons, and the pion plus. So, for a proton, which we know that has a charge of positive E, so it is composed of two up quarks and one down quark. So, two up quarks has a total charge of 2/3 plus 2/3 E. So, you would have 5/3 E. 4/3 E, and then adding in a down quark would result to 3/3 E or 1 E. So for a neutron, it is composed of a up quark and two down quarks. So adding in the fractional charges of these quarks would produce the total charge of the neutron to be 0. And for the pion plus, we have a up quark and a down antiquark.